This is May June 2022, paper 1-2. Question number 1 में कह रहा है कि equations involving four enthalpy changes are shown. Which equation represents the second ionization energy of sodium? Of course, second ionization means it has lost its first electron and right now it has a positive charge, and after losing the second electron it would be having a +2 charge. Okay, so that's why the first equation is of the first ionization energy, and the second equation is the first and second ionization energy. Okay, it's first and second ionization energy. And if you are going to subtract these two equations, of course, so first and second ionization energy minus the first ionization energy, that would be giving you the second ionization energy equation for sodium. Okay, A, B, and D, they are all are incorrect. Why? Because if you can see why is atomization, because solid is going to convert into the gaseous state. So this is an atomization. And if you can check Z, it's atomization plus ionization. We only need ionization. That's why I'm going to look at W and X only. Okay. Then question number 2. This question refers to isolated gaseous atoms in the ground state, in which atom are all electrons paired. Okay, all electrons are paired. So if you can see barium, so its configuration would be, of course, it's in group 2, so it would be having two electrons in the s orbital, and it's in the sixth period, so it would be having the configuration that is equal to 6s2. If you can check bromine, it's ending on 4p5. 4p5 means that it has an unpaired electron. And if you can check sulfur, sulfur is ending on 3p4. It's also unpaired. Okay. And if you can see silicon, that is 3p2, it's also unpaired. So option A is correct because in the barium, all electrons are paired. Okay. And if you can see question number 3, which sample contains the most iodine? Which sample contains the most iodine? So, first of all, you have to calculate the number of moles. Okay. So the mass is given to you in option A, that is 1 grams divided by the molecular mass of the whole calcium iodide, that is 166.9. Okay, then it would be giving you the number of moles. Then same goes with option B, then same goes with option C, then same goes with option D. Okay, so you know after finding out the moles, then what you would be doing, you would see that which is the like the greater answer. So that would be the correct option. So of course 6.9 exponent minus 3 is the greatest answer. So that is your correct option. Okay. So D is your answer. See question number 4. When a small sample of hydrocarbon is completely combusted, it produces 3.52 grams of carbon dioxide and 1.44 grams of water. What could be the structure of hydrocarbon Q? Okay, hydrocarbon Q. So Q is reacting with oxygen. Basically, it's being combusted and it's going to produce carbon dioxide and water. So you can see that they have given the mass of carbon dioxide, that is 3.52 grams. I'm going to divide it by the molecular mass, that is 44. Okay. And then they have given you the mass of water, that is 1.44. So I'm going to find out the moles. I'm going to divide it by the molecular mass of water, that is 18. Then I would be getting the moles of CO2 and the moles of water. So I'm getting the same moles of carbon dioxide and I'm getting the same moles of water. Okay, then you know what I would be doing? I would be writing down the combustion equation for each and every option, and then I would be looking after the balancing equation that in which option I am getting the same moles of carbon dioxide and the same moles of water. So I got an option B in which you can see I'm getting 6 moles of carbon dioxide and 6 moles of water, which means that I can I can relate this with the given number of moles that I found, that is 0.08 and 0.08. So on the basis of this, I can say that the B option is the correct option. Okay, that's it. And then you can see question number 5. Ethane, ethane and ethene are both hydrocarbon molecules. What is a feature of both molecules? What is the feature of both molecules? Option A is incorrect. You know why? Option A is incorrect because ethane is tetrahedral. Tetrahedral is a 3D structure and ethene is planar. It's not a three-dimensional structure. It's a planar structure. So they are having the different geometries. So option A is incorrect. Okay. Like this statement is incorrect for both molecules. It's only correct for the ethene. And if you can see option B, bond angles of 109.109 degrees, it's true for ethane. It's true for the tetrahedral one, but it's incorrect for the ethene because in ethene the bond angle is 120 degrees. Okay, and if you can check option C, so it's going to have only the sigma covalent bonds. You know what is sigma covalent bonds? Sigma means the single covalent bonds. So if you can see both structures, ethane and ethene, in ethene only one pi bond is present, but of course in the both structures you can see the single covalent bond, that is the sigma bond. So that's why option C is correct option. Okay, easy. Then question 6, कहता elements J and L are both in group 15. J and L, group 15 means group 5. And group 5 means that the configuration would be ending upon this S2 and P3. Let's check. Like nitrogen is in group 5 of the periodic table and the proton number is 7. So if you can see electronic configuration, that would be 1s2, 2s2 and 2p3. That's an electronic configuration for the nitrogen which is present in the group 5. So J and L each form a gaseous covalent hydride in which their oxidation number is -3. Okay. So in the liquefied forms of these hydrides, significant hydrogen bonding occurs only in the hydride of L. Which raw about J and L could be correct? Okay. So significant hydrogen bonding means that it should be nitrogen. Okay, because we have discussed in the chemical bonding in intermolecular force that hydrogen bonding is present in ammonia, like in nitrogen, fluorine, and oxygen, like phone. Okay, so nitrogen is one of them, and nothing is present. So I would be mentioning A and B. Okay, C and D are completely incorrect because they are saying in the liquefied forms of these hydrides, significant hydrogen bonding occurs only in the hydride of L. So L must contain nitrogen. Okay, this is the first hint for you. And then outer shell electronic configuration would be involving, of course, it's in group 5, so it would be ending on S2 and P3. That's why option B is correct. Okay, that's why option B is correct. It's very simple. Hmm, okay. Then question number 7 says which gas will behave least like an ideal gas at 150 degrees Celsius and 101 kilopascal. 150 degrees Celsius and 101 kilopascal. Basically, they are asking like to identify least like an ideal gas, which means that which is a real gas. Of course, which is a real gas. So how I would be identifying that which is a real gas? So real gas is the one in which you would see real gas is the one in which you could see the intermolecular force of attraction. Like noble gases are ideal gases. Noble gases are ideal gases. They are not inert. They are inert. Okay, they are ideal gases because they have no force of attraction. But if you can see the one which is going to have stronger intermolecular force, so you can say that gas would be the real gas. It's not an ideal gas because it has a force of attraction. Okay, so of course krypton is completely incorrect because it's a noble gas. It's completely ideal gas. Now the remaining options are A, B, and D. B is also incorrect because it's fluorine. Fluorine is diatomic molecule. It's non-polar. It's non-polar. So, generally, if you have a polar molecule, so it would be having some sort of intermolecular attraction. Okay. But if you have the the non-polar molecule, so it would be having attraction, but a weak attraction. It would be having attraction, but weak attraction, remember. So B is also incorrect. Then we have to decide between A and D. A for apple and D for doctor. Then what I can say? So in option A, you have ammonia. In option A, you have ammonia. Ammonia is NH3. And NH3 means that if you're going to draw the dot and cross diagram for ammonia, so you will see the one lone pair on nitrogen. And if you can draw steam, that is water, it's going to have two lone pairs. It's going to have two lone pairs. So it's going to have a stronger IMF as compared to this ammonia. As compared to this ammonia, so water is going to have a stronger intermolecular force. So it would be acting as a least like an ideal gas. Like it's more real. It's more real as compared to ammonia. That's why option D is correct. So indirectly, they are asking to identify the real gas. Indirectly, they are asking to identify the real gas. Okay, so you need to understand the essence of a sentence. Okay, then you would be answering the question. Okay, then question 8 says when an evacuated glass. Oh my God. Okay. Uh, when an evacuated glass bulb of volume 200 centimeter cube is filled with a gas at 300 Kelvin and 101 kilopascal, that is the pressure, the mass of the bulb increases by 0.68 grams. The gas obeys the ideal gas equation. What is the what is the identity of the gas? Okay. So PV is equal to nRT. Of course, this is the general gas equation. I know the pressure. I know the volume. Okay, I know the volume. I know the temperature. I know the pressure. I know the mass. I know the value of R. That is constant. That is 8.314. So I would be finding out the molecular mass. After finding out the molecular mass, then I would be matching that molecular mass with the periodic table. Then I will get to know that if I'm getting 82, so what's the MR? Like which molecule, which gas, or which compound is going to have this MR? So I have these options: krypton, neon, then nitrogen. I remember argon is 20, I think, 36, 36. And neon is 20, I think, and nitrogen is 28. Of course, it's not with this option, like with this answer. So there is one and only option, that is krypton. So then you will go to the periodic table and then you will see the mass of krypton. So I believe that that would be 82. So that's why this option is correct. Okay, so you can do this question in this manner. Easy. Then question 9 says the standard enthalpy formation of NO2 is 33.2. Okay, like the formation of this one is given to you, and the standard enthalpy of formation of N2O4 is plus 9.2 kilojoules per mole. What is the standard enthalpy change for the reaction this and this? Okay,
Else you can draw the Hess's cycle, or either you can solve it directly. Okay. So means that the formula is Pakistan Railway, product minus reactant. And if you remember, if the examiner would be asking related to the combustion, so the formula would be the reverse of this. That would be reactant minus product. And if he would be asking the bond energy, again the formula would be the same. That is the reactant minus product, the opposite of this. Okay, this formula is only used when you are going to identify, when you are going to find out the formation question. Okay, so that's why it's product minus reactant. Product is this, value is 9.2 minus, and reactant is this, that is 2NO2. So I would be multiplying this value by 2, 33.2 times 2. Then after the subtraction, I would be getting the value of delta H. Okay, it's very simple and very clear. Or, okay, then question number 10 says, separate samples of 25 cm cube of zero point 0.1 mole per dm cube NaOH are added to each of the three different acid solutions. We have H2SO, we have HCl, we have ethanoic acid. The temperature of each of the solutions was 298 Kelvin before mixing. Okay, before mixing. Like before, like they're saying before mixing. Of course, acid-based reactions are exothermic reactions. So when you would be mixing them together, so the temperature would rise. The temperature would rise. Okay. So means that the temperature would rise. So then what they are asking, we can see this. Which statement describes the temperature rises that occur on mixing each of these three acids separately with the sodium hydroxide? Okay. So they say the temperature rise in all three mixtures is the same. No, 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 no. You know why? Until or unless the concentration and the volume are same, until or unless the concentration and the volume are same, but sulfuric acid. If you can talk about sulfuric acid, it has an ability to donate two protons. It has an ability to donate two protons, right? So, of course, it would be releasing more energy. It would be releasing more energy. Okay. And then, so option A is incorrect because they are saying the temperature rise in all the three mixtures is the same. It's incorrect. And then B says temperature rise using sulfuric acid and HCl is the same. No, how is that possible? HCl is monobasic acid. It can only donate one proton, and H2SO can donate two protons. That's why. Then C says temperature rise using ethanoic acid is greater than using HCl. No, they have the same concentration and they are the same, like they are monobasic acid. They would be releasing the same energy. They are saying in D, the greatest temperature rise occurs using HCl. That's true because it's a diabasic acid. It has an ability to donate electrons, so it would be releasing more energy. It would be doing more reaction. It would be doing more neutralization. It would be releasing more energy. It would be more exothermic. That's why option D is correct. Okay. So you need to understand the basics of acid-base reactions, which is dibasic, which is monobasic, which is polybasic, like H3PO4 has an ability to donate three protons. Okay, so you must know these things to solve these type of questions. Okay, and question 11 says NCl3 reacts with water. Mhm. The oxidation state of nitrogen doesn't change in this reaction. Which statement is correct? So remember, whether if you can check this one, like I have calculated each and every oxidation state of nitrogen in the reactant side and also in the product side. So once they have told you in the question that the nitrogen is not going to change, so what does it mean? There would be no oxidation. There would be no reduction. Of course, this is not a redox reaction. Of course, this is not a redox reaction. Simply, and otherwise you can solve it. You will find after the calculation, like in the reactant side, it's -3. In the product side, it's -3. It's not going to change. So of course, this is not a redox reaction. It's very simple. Hmm, okay. Then question 12. In which raw do the oxidation numbers of vanadium increase? Okay. So, this question requires a lot of working and you have to do this. And you have to do this. You know how? Like it's +5. How it's +5? VO43 minus. So vanadium is your subject. Four oxygens, each oxygen is -2 is equal to -3. V minus plus minus 4 into 2 is 8 is equal to -3. Then V then is equal to -3. Then plus 8 then equals to plus the 5. That this is the oxidation state of vanadium. That is +5. Okay. Then VO3 minus says that, like again we have V plus 3 into 2 minus 2 is equal to -1. Then V minus 6 is equal to -1. V is equal to -1 plus 6. V is equal to +5. Again it's +5. Again it's +5. It's wrong because they are saying smallest to the largest. Okay. So then I did the same thing for the B option, same thing for C, and same thing for D. Then once I have solved C, then I got to know that it's +3, it's +4, and it's +5. It's increasing. It's increasing and it's decreasing. That's why option D is incorrect. It's also first it decreases then increases. But in the question they were saying it only increases. So we have to select the option in which the oxidation number is only increasing. Okay, that's why option C is correct. बहुत इजी पेपर है ये, बिल्कुल बेबी बच्चों वाला पेपर है यार ये, बिल्कुल बहुत आसान पेपर है ये. एंड देन क्या कहता है वो, क्वेश्चन नंबर 13. क्वेश्चन नंबर 13 कह रहा है that a synthesis for methanol is shown related to organic chemistry. Which condition gives the greatest yield of methanol at equilibrium? Also the chemical equilibrium. This reaction is exothermic. This moles of reactant, 2 moles of product. Simple. The greatest yield of methanol. Like the reaction would move in forward direction. Okay. So high pressure. When you would be increasing the pressure because you have more moles of reactant and less moles of product, so the reaction will move from higher to lower. Means it would be in forward direction. Okay. So high. We have two options, A and B. And then since the reaction is exothermic, so the lower temperature will favor the reaction. It would shift equilibrium to the right. And if you remember when we were discussing the Lee-Chatellier, I told you that you have an reaction. So if you're going to increase the temperature of the exothermic reaction, so that increasing temperature will shift the equilibrium to the left. Will shift the equilibrium to the left, right? So that's why option B is your correct option. Okay? बिल्कुल आसान है ये तो. So you must know the concept of equilibrium. That's it. Okay. Uh, yeah, let's try question 14. Then I would be telling you how would you do this question. Just try this. Just try. I'm going to give you only 1 minute. Acha ji, okay. I'm telling you this, okay. We have multiple methods to do this question. Okay. So they have given the moles of hydrogen gas and X moles of iodine vapor, like X moles of iodine. Okay. Uh, are mixed in a sealed container of volume 1 dn cube at temperature 460 Kelvin. Okay. The system is allowed to reach equilibrium. The equilibrium mixture contains 2 mole of hydrogen iodide. The equilibrium constant Kc for the reaction at 460 Kelvin is 4.0. What is the value of X? Hmm, Okay. So first of all, this is your equation. Okay. H2 plus Cl2, H2 plus I2 gives 2HI. Okay. This is your equation. And this is initial amount, amount reacted, amount produced, equilibrium amount. Okay. We did the same method when I was telling you this topic. Initial moles. Okay. So X mole of iodine, this is 0. The reaction has not started yet. So the product is 0. How much amount has been reacted of this hydrogen? I don't know. This is Y mole. I'm going. I'm not saying that this is X because it would be mixed together. Okay. I'm giving the different like variable to this reacted system. Okay. I don't know the moles of iodine. How much moles of iodine has been reacted? This is Y. The same thing. How much moles are produced for HI? I don't know. This is 2Y. Okay. Then the equilibrium mixture contains 2 mole of HI, that is 2 mole, and the Kc is given to you, that is 4. Okay. I told you this is your reactant. For the reactants, the equilibrium amount is equal to IA minus AR. IA is 4, AR is Y, 4 minus Y, it's X, it's Y, it's X minus Y. Okay, so the Kc has given to you, that is 4. What's the formula for Kc? It's product upon reactant. Product is HI, that is this. It's 2. 2 into 2 is 4. And we always put the moles that are present in the equilibrium amount, EA. Okay, so this is X minus Y and this is 4 minus Y. After solving this equation, I would be, you know, finding out Y, okay, and then I would be finding out the value for X. So you can see that X is equal to 1.33. X is equal to 1.33. So that is your correct option. So you can match with your solution. You can match with your solution. Okay. बहुत आसान है ये कुछ भी नहीं है इसमें जस्ट आपने इक्वेशन सॉल्व करनी है एंड देन यू वुड बी फाइंडिंग आउट द वैल्यू फॉर एक्स दैट्स इट ओके सिंपल
Sir, how did you find the value of y?
या since the equilibrium amount has given to you that is 2 what's the formula for the product for the equilibrium amount EA is equal to IA plus AP. Equilibrium amount is 2, initial amount is 0, amount produced is 2, nah, yeah, amount produced is 2Y, amount produced is 2Y. I have found Y, that is 1. I have found Y, that is 1. फिर मैंने इस 1 को यहाँ पुट कर दिया 4 minus 1 4 minus 1, that is 3. फिर वो 3x and then 3y. Then I have multiplied 3x and 3y with this 4. Then I got x. Because after finding out the value for y, you can solve this equation. Otherwise, if you have the two unknowns in the same equation, how you would be solving this equation? So then you would need the simultaneous two equations. I have only one equation. I would be dealing with one equation only. That's why I did this. That's why I did this. Okay, it's a tricky question. Otherwise, क्या होता है कि otherwise generally we always find the in this question KC is given. This question the KC is given. Okay. Now, uh, a large amount of N2O, a large amount of N2O decomposes into the nitrogen gas and oxygen gas in the presence of a tiny amount of solid foil, in the tiny amount of a gold foil catalyst. Okay, 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 okay. Then the gold foil provides a solid surface on which the catalyzed reaction takes place. The graph shows the concentration of N2O against time as it decomposes. The graph is a straight line. Okay. Which law describes the change in rate of reaction as N2O decomposes from 0 to 10 minutes? 0 to 10 minutes. Okay. The effect of adding more gold foil catalyst on the rate of decomposition of the same compound concentration. Okay. So remember, change in rate of reaction as the N2O decomposes. So change of rate is none. You know why? You know why? How can I say the change, like the rate is not changing? How can I say this? You know, the the we generally take gradient. We generally take gradient. That is y2 minus y1 divided by x2 minus. The gradient is constant. It's decreasing, like it's going very smooth. It's a straight line. The gradient is constant, so the rate is not changing. So change in rate, none and none. None and none. Effect of adding more gold foil on the rate of decomposition. So of course, this is a catalyst. This is a catalyst. So if you're going to add gold metal foil into the reaction system, so the rate would be increasing. So that's why option A is correct. It's related to the rate of reaction. It's related to the rate of reaction. Then question 16 says the Haber process for the manufacture of ammonia is represented by the equation shown. Which statement is correct about this reaction the when the temperature is increased? Okay. Since the reaction is exothermic, since the reaction is exothermic, so they are saying which statement is correct about this reaction when the temperature is increased? Both forward and backward rates increase. You know, I'm going to increase the temperature, so the rate increases. So the rate increases, not only the forward reaction, but also the backward reaction. Okay. Then option B says the backward rate only increases. How is that possible? This is equilibrium reaction. Once the forward reaction would be increasing, so the all backward reaction would be increasing, of course. C says the forward rate only increases. No, there is no effect on the backward or forward rates. No, there is effect. There is effect. The temperature can change the rate, of course. So that's why option A is correct. Okay. Question 17 says ammonia is added to separate samples of sodium chloride and magnesium chloride, barium chloride and SiCl4, silicon chloride. Under the conditions of this experiment, only two samples will produce a white precipitate when ammonia is added. What are these two samples? Ammonia is basic. Hmm? Ammonia is basic. So so the base can react with an acid. So the base can react with an acid. NaCl will not react with ammonia. It's a simple salt. It's a simple salt. Okay. Or when you are going to add sodium chloride in water, it would be producing the Na plus ion and the Cl minus ion, of course. Okay. So when you have magnesium chloride, okay, when magnesium chloride would be reacting with water, would be adding in water, so it's going to produce magnesium hydroxide and hydrogen chloride. Magnesium hydroxide and hydrogen chloride. It's a weak base. It's a strong acid. It's a weak base and it's a strong acid. In the case of sodium chloride, in the case of sodium chloride, NaOH and HCl were producing. Since both are strong, they would be cancelling each other. As a result, the overall solution is neutral. So that's why I cannot say that ammonia would be reacting with this. When you are adding magnesium chloride in water, it's going to produce weak base and strong acid. So a strong acid has a dominant effect. So that's the reason ammonia would be reacting with this MgCl2, of course. Okay. And then also you can say that like magnesium hydroxide is insoluble in water. Magnesium hydroxide is insoluble in water. It's solid. It says only metals will produce a white precipitate when ammonia is added to and then if you can see SiCl4, it's adding in water and it produces silica, SiO2 solid. It's also a white precipitate. It's also a white precipitate. So that's why option B is correct. You know why C is incorrect? Because first of all, it has sodium chloride. And why not A is correct? Because magnesium chloride is correct. But why barium chloride is incorrect? Because barium chloride, when you are going to add this in water, it's going to produce HCl and barium hydroxide. Barium hydroxide is a strong base. How do we know this that this is a strong base? Because it's more soluble in water. Because it's more soluble in water. Remember, because hydroxide ki solubility increase down slope. That's why it's more. It would be giving us more OH negative ion. Okay, so its pH would be higher, so it's a strong base. If it is soluble, it's not going to give you a white PPT. That's why. Okay. So that's the reason option B is the only correct option. Okay.